Okay, now in this section we will be going over some materials which are specifically designed for the integrals of trigonometric functions. Now as the start, we will go over the method of solving the integral of cos cube x, right? And also at this point, I assume that you have a basic knowledge in using substitutions for integrals. So if you are not familiar with that content, I think it's better if you go over those materials first and then come back here, right? Okay, so for this integral, it's natural to use the substitution of u equals cos x, right? But there is a small problem here. Now, with this substitution, we will be converting this integral to the terms of u, right? So this integral is in terms of x, and then along with the substitution, we will be converting it in terms of u, right? So this becomes u cube, and what should we replace instead of dx, right? So we can't just write du here. We should obtain a suitable relationship that is compatible with this equation, right? So that's how the integral substitution works. Okay, so to find that relationship, we should differentiate our equation of substitution, right? Then this becomes negative sine x, and du will be equal to negative sine x times dx. Now this is the problem here. So if we have this term in the original problem, we can replace it with du, okay? But in the problem, according to the way that they have given it, we do not have such a term. So although this substitution is the natural way of starting it, we will not be able to proceed through this calculation as we don't have the negative sine x dx term. So instead, what we can do is, still we can use the same substitution, but before going for that substitution, we should make some rearrangements for the initial problem, right? Now for that rearrangement, we make use of the standard trigonometric identity, okay, which is sine squared x plus cos squared x equals 1. So therefore cos squared x will be equal to, cos squared x will be equal to 1 minus sine squared x, right? So now in the original problem, we can rearrange it like this. Cos cube x can be written as cos to the power 1 times cos squared x is the same thing. And instead of cos squared x, we can replace it with this term. See, now we have both sine and cosine terms emerging from the original problem. The reason for doing it is, when using this sort of a substitution, like if we are substituting in place of cos x, we will need sine x dx term. And if we are substituting in place of sine x, we will need cos x dx term, right? So that's the nature of the calculation associated with the substitution, okay? Right. Now what we can, so this is a very standard procedure, so we must be familiar with that, okay? Right. So here we can distribute the integral and write two integrals like across this addition, right? Then so it becomes cos x dx minus sine squared x cos x, right? Now we know the answer for the first part, right? The integral of cosine x dx is a standard integral which is equal to sine x, right? And for this part, now we have an integral with both sine x as well as cos x, right? So for this one, we will use the substitution of u equals sine x, right? Then it will it will have a very smooth flow, right? The reason is now to substitute in place of dx, we need this calculation, which is sine x, should be cos x, and then du is equal to cos x dx. And now see, in this integral, we do have the cos x dx term, right? Therefore, instead of this term, we can write du, okay? So this portion of the integral becomes, since sine x is equal to u, we can write it as u squared, and as we have cos x dx, we can write du instead of cos x dx. Then we can easily integrate this term, or this question, or the new problem with the standard results we know, right? Then that means the answer for this original given problem is this, right? Now, as it is given in terms of x, we should convert everything back into x terms, right? Sin x is already in terms of x, but we should convert u with the substitution that we used at the beginning, right? So which is sin x, right? Sin x cube over 3, and don't forget to have the arbitrary constant. Now the key point here is that at the very beginning we tried to use the substitution directly, which is now, since this is in terms of cosine x, we were trying to use the substitution u is equal to cosine x, right? But there was a problem of this term. This term was not there in the original problem. So we used the trigonometric identity and then extracted some sin x and cosine x terms from the given original problem. And when doing the simplification in that way, we came across a situation like this, right? We were supposed to integrate this term, this function, sine squared x times cos x. Now for this function, our usual or the trivial substitutions will work, because we had a sine x term which we are using for substitution, but along with the sine x term, we had the cos x dx term. So it is very compatible with the substitution techniques, and hence we can easily find the answer. Okay, and in the next video we will go over some slightly more advanced techniques for integrating these trigonometric functions.